competent to speak on these kinds of matters because I come from the sort of standard modern academic tradition of physics. I can't claim to having a great acquaintance with tradition, but nevertheless, like all parents, I have a connection to education. I have witnessed first one kid and now another going through our very non-holistic, very non-integrated system of education. In fact, my younger son's physics practical board exam starts tomorrow. So I think I'm qualified in that sense to talk on this subject. Now, I took the trouble to prepare a text which I mailed to Srinivasa, which is at the back of this booklet because it came in last. And I'll use that in part. And I'll also say a few other things, and I'll try to stick to a 15-minute limit like the previous speaker did. So I'm very happy to see that Purna Pramati aims for integrated and holistic education in which values, leadership, all these kinds of things, as well as technical knowledge go side by side. But as Indians, we have to realize one thing, and I think this point was brought up by Mr. Sangal when he mentioned earlier, which is that despite our many decades of independence, we don't have a working, universal, conventional primary and secondary education system. We have bits and pieces of it. So even though we're talking about improving what we have on the national average is terrible. Okay? Effectively, most kids don't get to go to an adequate school of any kind. The percentage of school kids of school age actually attending school is too small. There are lots of places in the public literature where you can find the chilling statistics on this subject. So you should always keep that in mind. So I would say that quite independent of a really integrated education, if we could get the kind of fairly ordinary education that most of the people in this room had to everybody in the country, that would already be a revolution. I think many other things would improve after that. So I think we need that perspective. Over and above that, if we take those people who went to reasonable schools, if you look at how they learned, they were taught, even at the most successful places, in a fairly unimaginative manner. Even those who went to places that really launched them into top-of-the-line career paths were taught in a hideously overweight syllabus. They were trained very narrowly in a clever kind of problem solving, but typically problems posed theoretically, not posed by observing the world, not posed by problems that beset them in everyday life. And there's another point, which is the main focus of the first part of my presentation, which is that typically if you do well in school, you are channeled into science and maths. You stop doing anything other than science, maths, and maybe a little bit of English usually by the age of 15. After that, so this is actually astonishing for a democracy. From the age of 15, you have kids being trained at the best places very well, narrowly in certain things, but actually spared the need to worry about civics, about the constitution, about the electoral process, about larger public issues, except through maybe sporadic debates they run into in television, which probably they aren't allowed to watch because they have to go to their coaching classes instead. So, it's actually a very strange situation, which is that the kids who are performing the best are really kept away from issues other than very narrowly scholarly and technical ones. Okay? So, I had sort of listed, I had mentioned in my little text presentation that I don't feel really competent to talk about things like values and ethics. I can at least talk about this divide between science, technology kinds of education and humanities-based. I also notice with some pleasure that Purna Pramati seems to want to base its training starting in the humanities. I'm not sure I completely agree with that. I would like a balance, but I think broadly, I think there's common ground there. So, so this is one point I wanted to say. And it's important to realize that a kid that chooses science in school and does science for the next 2 to 4 years, then goes to college, again into a science or engineering degree, again, and especially if the kid goes to a standard engineering college, or even more narrowly goes and does a BSc in some science subject, you are further specialized. You really then spend even your college days, which is your first experience of the outside real world, again in education which is narrowly focused on technical issues. So some of these kids then go on to do very well in the technology sector, some others maybe go on, maybe do management or something. Maybe if they do management, they learn a little bit about the world. But in my education, for instance, certainly, or if you look at many of my colleagues, they really have reached not just adulthood, but a PhD and a professorial position, largely not having formally in school or in college thought about these social issues. As I said, of course, they're intelligent people, and therefore presented with a set of facts can doubtless make rational intellectual judgments on them and think about policy. But I think you would produce a very different kind of person if right through school and right through university, your education wasn't made narrow, was spread across subjects. And see, even within what I guess you could call the Macaulayan setup, even if your syllabus material was not that different, if you at least had a healthy dose of the humanities, of the fine arts, of history, etc., I think you would already make a different kind of person, even without radicalizing education. You could already make a big difference. And history is one thing I think it's particularly important because many of our present conflicts are because we choose not to be aware of our history. The same issues come up time and again, the same historically incorrect positions are adopted rigidly by people in arguments, which you see, let us say, on television. The response of the public, if you look at reporters going and asking people questions on the street, or you look at the sorts of questions that you see on television programs where public figures and the general public talk to each other, you find a surprisingly poorly informed public, even when drawn from people with nominally a very good education. So it seems to me this is a national disease, and it seems to me if this continues in the long run, even as education spreads, we'll have a technically trained, but I think the words I used, I can't read them without my glasses, are a technically trained but socio-politically and ultimately ethically illiterate population. So that is one part of what I wanted to say. The second part, which pertains to integration in a different sense, also connects to what is taught in class and what is happening in the world around you, but not necessarily to the science versus non-science divide. Even if you pick the way any given subject is taught, if you pick the way science is taught as revealed wisdom, it's taught as stuff in books, it's taught as something the teacher, a figure of authority, comes and tells you. Increasingly, I find in schools, the experimental or observational part of science is taught merely as a later adjunct. The boards are coming up, we better finish these 8 experiments, let's go on to them. You can actually teach science in a completely different way. You can actually teach anything, history, sociology, whatever it is, in a completely different way. You present people, in fact, not even present people, you encourage people to look around themselves, see things that puzzle them, that disturb them, ask them to make up their 0th order story about why it's happening, ask them to make it up to the extent that they can put it to the test. I mean, let me give you a completely trivial example. Let's not think of history or philosophy, let's think of physics. You open a tap and you watch the stream of water. As you know, if you open a tap and watch that narrow stream of water, it is fat at the top, and let's ignore complexities like dripping or chaos or something. Look at a smoothly flowing stream. It's fat at the top and gets narrower and narrower, it goes to the bottom. It turns out that a 9th standard or 10th standard kid knows enough physics that you can get that kid to formulate a quantitative theory of this, take pictures, measure everything about it, compare it to the theory and see if it's right or wrong. So it's very important in your teaching stuff to empower the kid to ask a question and to be able to answer it, and then to be able to go and test if the answer is correct. If you take sufficiently simple things, but still non-trivial, you can actually get them to work with these things. There's one example. Take another example. You take a coin and drop it at the ground. It goes tick, 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 and more rapidly, and eventually settles down. Or you drop a plate in the kitchen, steel, not glass, plate in the kitchen. Similar thing happens. And what you find is it vibrates more and more rapidly before coming to a stop. You can ask a kid why it's happening. You can certainly ask a 10th standard kid to formulate it. Maybe by 11th or 12th, you can ask them to formulate it completely enough. They can make a rough quantitative theory, see what's right, see what's wrong with it. You can, of course, go to larger things. You can ask them, you look at a tree, and why on earth does a tree have a branch structure? You can look at a river, you can look at clouds. You can look at stuff in the world around you. If you could teach science and everything else this way, by posing questions based on phenomena the kids themselves observe, themselves handle, and then going on to analyze the subject more quantitatively, you would really produce a different kind of human being. However, to do this, you need to do one thing. You need to require them to know less. At the moment, at least it looks like the Central Board of Secondary Education thinks you have to know everything by age 17 or 18. And then, in addition, it is decided that, they're doing all this rote learning, book learning, there must be projects. When they add that, that becomes only an additional burden on the parent, and not, because there's already tons of stuff in the book, in the syllabus, they have to learn. Pretty much every single subject is taught this way. Many of the books I find are improving. If you look at books produced by the NCERT, actually they're quite nice. They're certainly better than what I had. They're particularly nice in the social sciences. They're somewhat too heavy in the sciences, particularly in chemistry and to some extent in physics. But I think we, some sections of our society have shown that we are competent at producing good textual material for students, accessible, conversational, communicable across different languages, cultures, all that stuff. I think we've actually got good at that. It's a very good sign. If, in addition, we could just ruthlessly remove things that the kid can do without, you can actually improve education, again, without necessarily a very radical experiment. It's radical compared to what we now do, because we now think that they have to learn and internalize everything. But this is another thing. So lastly, I'll say one word about my own work. My own work these days is of physics in biological systems. And a lot of it actually was motivated by just watching phenomena, watching bird flocks or looking at collections of bacteria, seeing what kinds of analogs they can make. And I would say there is a large trend in my area of physics, condensed matter physics, not to work in what Sri Darshan Shankar called silos. We think about, with a physicist perspective, about problems in biology, about problems in engineering, about social behavior. We try to make analogies between one and the other. My friend Vishu sitting in the audience and Vishu is a good example. He started out as a physicist and he now does ecology. So I don't think merely because we've been technically trained very strongly in one subject condemns us forever to work in that subject. Certain ways of thinking translate very nicely to other areas. So you can break out of the silo because you have learnt one discipline well. And I think, all of this is something you can do if you teach science in this questioning way. Science and, as I said, other things. So I think that's really all I wanted to say. So I'll hand over to the next presenter.
So as a scientist, if one is theorizing, then how does he observe things? And perhaps also more importantly, how he or she engages in doing things. Doing things is preparing for life, so also going beyond education. There's a third aspect, which is the heart. So the brain, the hand and the heart. Integration of these three is education. How to achieve it? Are we forgetting something? I think by and large we have forgotten the last two. The education has become education of the brain. Rationality, mathematical reasoning, scientific reasoning, even social science reasoning. Somewhere the heart is missing and the hand is missing. So how do we put these three together? This would be a question. And this is not just a question about India. It's a question about the world. In India, we may be doing the brain education little less well or pretty badly or whatever. But what about the other two? So the issues that are there, which are facing the world today, are not just issues of India. They are issues of the world. So I'm sure we'll, connect back. So I request now Professor Abhay Ojha from IIM Bangalore to speak.
Thank you. Let me begin by thanking Purna Paramati for inviting me here. As some